Hey everybody, and welcome to FRM 120, Brewery Facilities and Operation Management. My name is Mike Deal. I'm your instructor for this class, and this is lesson one. We are going to be talking about safety in the brewery. I know maybe not the most sexy of topics, but it is probably not the most exciting either, but it's one that we really need to cover because there are a lot of safety hazards or potential safety hazards in the breweries that you're going to either work in or possibly own, or at least do your practicum hours in. So we want to make sure that we kind of cover generally with the things that you'll see and the hazards that you'll need to be on the lookout for. Again, I'm not going to go into great detail in this lesson, but this is we're going to cover just kind of like I said, the hazards that are involved in a brewery. They're going to consist of general housekeeping, slips and trips, proper lifting, ladder safety, dust and particulates, chemical hazards, electrical hazards, fluid power hazards, and thermal hazards. So like I said, we're not going to go diving deep into all of these. We are just going to hit on them and kind of give you an idea of what you're going to run into. When you go to your local craft brewery, you don't typically think of it as an industrial site. Most of them are locally owned and operated. You kind of go in there and it's a real easy, relaxed vibe. And it's not, like I said, not considered an industrial site. And you don't really think about industrial hazards when you're in there. But there are some. And even though this next example is not a brewery, it's a distillery. It's one that had some issues that impacted the environment and also the community around it. And that's over in Lawrenceburg, Kentucky at the Wild Turkey Bourbon Distillery. And again, I know this is bourbon, distilled spirits as opposed to beer, but the hazards are very similar, okay? It happened back, oh, and by the way, if you've never taken this tour of Wild Turkey, it's really one of the better tours on the Bourbon Trail. It's in Lawrenceburg, Kentucky, sits high up on a limestone bluff. And they, on May 17th of the year 2000, they had a rick house, which is where they store all the barrels of bourbon. The rick house caught on fire, and I don't really remember what it was that caused the fire. But anyway, it caught fire, the one rick house did, and they lost 17,000 barrels of bourbon. And that was about 20% of their inventory. And of course, when the oak barrels burn, of course, the bourbon's going to leak out. And as I stated earlier, the distillery is sitting up high up on a limestone bluff, and it naturally went down, gravity pulled it down into the Kentucky River. It contaminated about 66 miles of the Kentucky River, and in doing so, it killed about 250,000 fish. And it also impacted the regional drinking water. They had to shut down schools, some businesses and hospital, all because that is their water supply, and it was contaminated with bourbon. I kind of hate to use the word contaminated and bourbon. It doesn't seem to go together, but let's just say that the bourbon went into the water, okay? I think it could have enhanced it myself, but anyway, this is what happened though. So you got hazards that impact you at these distilleries and also these breweries. But this is one that happened here, not too awfully far away from us. It was a big global news story at the time. But like I said, when you go into your craft breweries, most of them have nearly all of this same equipment. The process, as you've probably figured out by now, for those of you who've taken the 100-110 class, the processes are the same. It's just each brewery does them a little bit different, and they also have different equipment and different equipment manufacturers. But they have pretty much the same type of equipment as the large scale commercial breweries. They use the same chemicals, they use the same electricity, fluid power, mobile equipment for some of them, and they require a lot of lifting and manual labor. And also the smaller craft breweries, the locally owned breweries, can have the same, if not more, of the types of hazards. And what I mean by that is, like for example, a lot of these breweries are on a shoestring budget, and they have to watch every penny. So they don't have the luxury of deep pockets that can afford them forklifts and a lot of ergonomically safe devices to help them avoid accidents and things like that, and injuries and things like that. So that's why I say that they have to be extra careful, because sometimes they can't afford the equipment that alleviates some of these. But there are ways to alleviate the hazards, as you'll find out. The Brewery Association put out this nice little chart of all the different type of hazards in the breweries. And I'm not going to go into detail on all of these, but we're going to talk about just about every one of them. We got electrical and pressure, and by pressure, we have kegs under pressure, but we also have CO2 and oxygen under pressure, and we talk about, we're going to talk particularly when we get into the fluid power portion of this class, how 1,000 PSI, what does that mean, PSI, pounds per square inch? What does that translate to? Well, you'll find out that particularly with these cylinders of gas, they can become missiles, and they have a lot of force and a lot of power behind them if something were to happen to them. So that's what we're talking about, pressure. Of course, there's going to be temperature hazards. Obviously, we're dealing with boiling liquids. We're and also just hot liquids out of the hot liquor tank and things like that we use. Slips and falls, we're going to talk a lot about that. The ergonomic issues that, there's a lot of lifting involved, from kegs to bags of grain, things like that. Elevation as far as ladders and things, there's particularly on wet surfaces and how they can be hazardous. Flammable explosives, sharp objects such as glass and metal. We do, they do their canning and they do their bottling as well. They're smaller, they still have their own canning and bottling operations. There's noise factor, mobile equipment, which is always a big one there, and mechanical issues and chemical as well. But this is just a quick list of some of the hazards that you'll see in a brewery that I found, and I thought I'd throw up there on the slide. But what we're going to talk about most of this lecture is the 5 most common brewery-related accidents or reports made to OSHA, the Occupational Safety and Health Administration. They have the federal, and they also have the state agencies as well, like local, state and federal agencies. But I thought I'd go over the 5 most common in the brewery industry. We'll start with number 5. The 5th most reported incident out of a brewery to OSHA is the permit required confined space or lack thereof. Okay, so what a permit required confined space it has 3 elements in order for it to be considered a confined space where a permit is needed to stay legal. Okay, so it has to have a large enough area so that an employee can bodily enter and perform the assigned work that or task. And in this picture here, looks like the person is going almost like in a bright tank almost, but he is crawling through that manhole, so he's going to be able to get in there so he can enter. It has to have limited or restricted means of entry or exit. Obviously, this is very limited. It's small, but it's also the only way in and the only way out too. So that creates one of the elements for it to be considered a PRCS. And also, it's not designed for continuous occupancy. In other words, they're to get in there and do the work, get in and get out, and they won't be able to hang out in there during the process. So in other words, obviously somebody's not going to be able to sit inside a mash tun while it's working or anything like that. So that it's not meant for occupancy other than just to go in there and get the work done. So all 3 of these conditions have to be present in order for it to be a PRCS, according to OSHA. Now, there are a couple of other requirements that we're going to talk about, and when we do talk about it, I've got a large 100-barrel fermenter drawing here on the screen, and so we're looking at very large vessels, not like the ones that we have in the lab, which is a single barrel. It's it's not confined space, and it's going to be hard to really stay contained in there. So that's not what we consider. But this 100-barrel fermenter, definitely, yes, that would be a confined space. It also has to contain or have the potential to contain a hazardous material or hazardous atmosphere. And as you know, that during the fermentation process, CO2 is emitted by the yeast, and therefore the oxygen is displaced, and you have a CO2-rich environment which cannot sustain human life. So this becomes a hazardous atmosphere. Okay, and also has to contain a material that has the potential for engulfing its entrant. Okay, in other words, a person can become entrapped in that vessel. Most of the times you see these on the road along farms, also around large granaries. These are silos, and they hold a tremendous amount of grain, barley, corn, whatever the case may be, but that holds a lot of that material. And one of the hazards is when the owner or operator has to empty this vessel or the silo here, they turn an auger on and it feeds from the bottom naturally, okay? So it's going to feed from the bottom, and as it feeds out, it carves out, it pulls that grain out like that. And sometimes the grain, particularly corn, as I've known from my own personal experience, corn will bind depending on the weather. If it gets humid enough, moisture enough in there, and dry, it can get hard and cling. The kernels can cling together, and they wind up holding, you know, a wall. And what can happen is a person can fall down there. Then subsequently, the grain walls collapse on that person, therefore trapping the entrant, as the OSHA requirement said. One other way is, and I've seen this personally myself, the material has been pulled out of the grain bin, and this bonding of the material, the corn or the oats or the barley or whatever it is that you have got in here, will bind and create a bridge. And it can sustain a significant amount of weight. A person can get on there. And I've known one of my friends' family members lost his life as a result of this bridge caving in, and he suffocated through entrapment. But it's a very dangerous operation here. So there are other mechanisms that you can have in here to make sure that it doesn't happen. But just want to give you that example. But it also has to have, the additional hazard that a PRCS has to have is integral configuration that might cause an entrant to be trapped. Okay. In other words, if there's no other exits or other than that one entry door that we talked about earlier, and it can't contain any other recognized serious safety or health hazard. Now, in a brewery, you'll see a lot of times a cold room. That's where kegs are stored. Okay. Well, this can be considered a confined space because it has one entry and one exit only. Also, the refrigerant up here can create a hazardous condition, very, very cold. You could die from hypothermia if in there long enough. And also, there's a seal around this door, and that door seal can deplete the oxygen, or will not allow oxygen to enter into the cooler, and the person consuming the oxygen there will eventually deplete it. And so that is one of the other conditions that creates this confined space and the other hazard. Some confined space examples in a brewery. Of course, I showed you the walk-in cooler, but this is a mash tun. Okay, and for those who have not been to one of the larger partner breweries, like I know that Dry Ground and also Hopkinsville Brewing Company have this configuration in their mash tun. This is a Raking Plow system, okay? And basically what this does is these arms that are sticking down in this rake along the bottom here, what it's doing is it's basically a automatic mash paddle, okay? It's mixing that mash up so that you don't have dough balls and air pockets and things like that. So it gives a good thorough mixture. And in doing that, it's all stainless steel, and it drives around in a circle, rotates around in a circle, and it's driven by an electric motor on a gearbox, and that gearbox ratio is very low, and the torque on this thing is very powerful, so it's going to be very unforgiving to a human body part that's sticking in there or trapped in there as well. But that's inside of a mash tun. Inside of a fermentation vessel, again, after fermentation is over, you open the vessel up, and there's a lot of CO2 still in the vessel because you've purged or displaced all of the oxygen, and therefore CO2 is left in there, and so it is a CO2-rich environment that can't sustain life, as we talked about earlier. This is just some large examples of the fermentation vessels and bright tanks. And fourth, number 4 on the list of related filings with the OSHA as far as safety or hazards in a brewery is general duty. Now, the definition, as OSHA says, is general duty mandates that employers provide a workplace free from recognized hazards that cause or are likely to cause death or serious physical harm. It's kind of a mouthful. But I'll give you some examples. For example, ergonomics, picking up the kegs and things like that. That is one of the hazards. That's one of the general duty hazards that you'll see in a brewery. You're picking up 55-pound sacks of grain that need to be milled. So that's that's an ergonomic hazard as well. You're lifting kegs, placing kegs. Even in our milling, in a smaller operation like this, we do this in the lab. We pick those 55-pound bags of grain up, and we typically will put it in a 5-gallon bucket and then go into our mill. But in this case, this guy's standing there holding a 55-pound bag of grain and kind of in a precarious position, and it's taking him a really long time to empty that bag too. So he's going to be there a while. But anyway, that's my point, is just one of the ergonomic issues. When we empty a mash tun, you're reaching in there and you're pulling. It puts a strain on your back. Also, we talked about that raking plow system. Something this big will have a raking plow inside there. So the motor that runs the gearbox that then turns the raking plow, it needs to be locked out. And we're going to talk about lockout tag out just shortly. But it goes into, we go into a little more detail with that, but you're pulling on that. That's the best case scenario. But if it were to become energized, it could tear up your equipment with the rake there. But even worse, if you've got a body part hung in there when it came on and you didn't realize it, it could harm you. It could hurt you really bad. So that's just another one of the hazards. And the failure to mitigate the dangers associated with the heavy or improper lifting are frequently cited under the general duty clause. So all of these examples, we talk about lifting the bag, going into the mill, the kegs, and the raking out of the mash tun. Those are all issues that need to be mitigated, and they fall into the general duty category. It also includes hoses, pump carts, spilled cleaner, water, and unfortunately spilled beer. That's never good. And ladders or staircases. Now, most of you have been in the brewery, the partner breweries, and also in the lab as well. So you've seen all these. We're going to have some more examples of these as well a little bit later. The number 3 is the process safety management of highly hazardous chemicals. Again, OSHA has a mouthful of words to say that these required chemicals on site have to be managed properly. They have to be accounted for, and they have to be mitigated in the event they're released into the atmosphere, or if an employee comes in contact with one that is hazardous to their health, they have to know how to mitigate that situation, to administer first aid or the proper care should they get in contact with these chemicals. And like I said, they have to maintain the proper paperwork on site, and that comes in the form of MSDS or material safety and data sheets. These have to be on file as well and up to date. If they were to change, you have to replace the MSDS with the latest revision so that it's accurate. And again, we talked about these are general cleaning solutions, they're caustics, they're sanitation materials that are all considered these chemicals that have to be accounted for and properly controlled and managed. Also, along that list is the different vessels that we have that contain our different gases. Again, CO2 and oxygen. Again, when we get into the fluid power, we're going to understand what force these have. These are to be chained to the wall or to a stable cart so they can't fall over. If they're not in use, then they need to have their cap. None of these have their cap on, except for maybe some of these down here, these propane or these argon and nitrogen bottles. But these should have a cap on them when they're not in use. Should they turn over and the valves snap off, all of that pressure is released through a small orifice, and like I said, these things can become missiles and hurt someone very quickly and very badly. Again, CO2, oxygen. We have glycol as far as our refrigerant to be able to drop our beer temperature once it's finished fermenting. We crash it, and we use the glycol as our refrigerant to drop it below 32 degrees so that we can get it really cold during that process. Ammonia is used, it's an industrial refrigerant. Mostly you see a lot of these used at food processing plants, but there are some very large breweries that use ammonia. That is a very specialized refrigerant or chemical used as a refrigerant gas, and it takes special certification, special training, and special contractors to come out and deal with ammonia. Your brewery operators are not going to be using ammonia, or at least handling ammonia on their own. So, but you won't see that a lot in the smaller craft breweries. It's mostly the glycol systems. Now, the second most reported incident in breweries to OSHA is the control of hazardous energy, or lockout tag out. I mentioned that a few minutes ago. So lockout tag out is basically putting a physical lock on a device that disconnects potential energy that could be released and hurt someone, okay? Whether it be electrical or fluid power, compressed air, hydraulics, those are both fluid power, some mechanical released energy that we'll talk about in a second. But this lockout tag out, for those who may not have been around industry enough to know this, it is to prevent the accidental startup of machinery, okay? One example that I talked about earlier was that Raking Plow. You know, you want to be able to lock that out before someone goes in there and starts working, to prevent the accidental re-energizing of that circuit that brings it on. Accidents don't ever happen on purpose, okay? People don't intentionally try to hurt people, at least in the places I've worked they haven't. But they do happen. Unfortunately, I've been in a plant where 2 of my coworkers were killed on different incidents. They had the electrical part locked out, but they did not lock out the accumulator on a hydraulic system, and that accumulator had the system pressure still maintained. That's what its job was supposed to do. And they were working on the machine, and somebody came by and actuated one of the valves, and when it did, it released the stored energy in the accumulator that drove the cylinder, and it crushed the guy and killed him on the spot. Sadly, the same accident happened about a year and a half later. Same machine, same process, same everything, just a different person, and that person died as well. So the lockout tag out part, there's different ways to lock out different types of sources of energy. This one is electrical, but there's so many more than just electrical, okay? But again, we don't want the accidental startup of the equipment. We don't want the unintended release of stored energy, which is what was in that accumulator. And we want procedures. These are step-by-step procedures that show us how to disable a machine completely for a task that we're trying to operate. Now, you may not have to disable the entire brew house. You may just have to be able to shut one part of it down, which you should have procedures that say, okay, if I'm going to go inside the mash tun, here's what I need to isolate. I need to isolate this electrical panel. I need to isolate this control power, things like that. So, but there should be some procedures to do that. And so there's some devices out there that are available. You can lock out just about every device. I showed you this one here hanging on a disconnect, the power disconnect, kind of like one we have down in the lab. You can hang a hasp on that, and anybody working inside the vessel, and these are particularly larger vessels, can hang their lock on here, but we do want to isolate that electrical energy. This one here is a valve. It could be a steam valve. You know, some of our brewers have steam-jacketed hot liquor tanks and mash tuns, so they have to contain not only electrical but also the steam as well. So there's these clamshells that go over it so nobody can grab hold of that valve and turn it. This is a ball valve lock that will prevent it from swinging back and forth. It blocks itself with the pipe. There's circuit breaker lockout devices, and so there's a lockout device for just about every source of energy, or the ability to shut down any source of energy. And I threw this one up here. I know this is a tractor, this is not a brewery, but this is fluid power. In other words, and you'll see this with mobile equipment though. So you've got a cylinder holding up the outrigger here, holding the tractor up. It's suspended in air. And should this hose right here become cut, then all of a sudden that fluid's going to shoot out. You're going to lose pressure on your cylinder, and its natural inclination is going to want to collapse under the weight of that tractor. However, we've got a mechanical barrier there, that so should that hose be cut in two, it collapses until the cylinder pinches this mechanical block there, and it keeps the tractor suspended in air so that no one gets hurt. Same thing with this tractor. And I also happen to know a gentleman that was working under a grain truck with his bed elevated like this, and one of the hoses that he accidentally disconnected one of the hoses on the cylinder, and I think he was trying to tighten it, but he went the wrong way, and it loosened and released the pressure, and the bed came down there and crushed him. So yeah, these accidents happen. And again, these cylinders are the same types of cylinders that on the mobile equipment, as in fork trucks and things like that, okay? But the number one most cited thing in breweries is the lack of use of PPE, personal protective equipment. Okay, and that includes your hard hat, your gloves. If you haven't got brewer gloves, get on Amazon before you come to the lab the next time and see if you can get a pair of brewer's gloves that will protect you from some of the hot work that we transfer. We've not had any real burns, but we don't want to take that chance. Okay. Also, you want to have the right boots and also the right safety glasses as well. But your PPE considers boots, your glasses, a respirator for the milling process, and a hard hat and others that are particular to the hazard that might be on site. I went through our, kind of did a mental checklist of what we do when we brew here at the lab, and kind of went through it and came up with a list of the hazards throughout the process. And this is just kind of a quick hit list. But with milling, some of the milling hazards are lifting, as we talked about. Proper lifting with the legs and not the back. A lot of companies will put these back safety classes on, but I'm sure at some point all of you have been instructed that you are to lift with your legs and keep your back straight and not pivot with your back trying to lift things, because you will really run the risk of hurting your back. Also pinch points when we're milling the grain. Now our mill is small, but if the handle is small enough, I looked at it yesterday, you could get your hand down in there enough to where your fingers could get in between these fluted rollers. Now these are fluted like ours are. Some of them are knurled that kind of come together, but these are fluted. It gives a better crush. It gives a better crush. But you can get your fingers hung in here, and they're also geared as well, geared and very low, and they're going to be very unforgiving. But it's a pinch point that's involved. Also respiration. Now we don't have a real problem with respiration, no matter with the little amount of milling that we do. However, some of the breweries that I have worked in has got a lot of milling going on, and you can look at the walls and there's dust all over. It's always good to have your respirator on, but also milling can create an explosion hazard. There was in Henderson, it's been about 15 years ago, I think it was, one of the grain mills over there where the farmers brought their grain for storage and an eventual sell out on the market. They stored the grain there, and they had some spontaneous combustion. I'm not sure exactly what caused it, other than it being spontaneous combustion. And there was an explosion, and it killed 2 people in the mill. So, the spontaneous combustion, anytime you have dust in the air, it's susceptible to static discharge, and that can cause an explosion as the rest of the dust were to ignite. So as we move forward, we got to prep our hot liquor tank for the brewing, okay? And what we're dealing with here is we're dealing with electrical issues, okay, we're hazards for the elements that heat the water in the hot liquor tank. Now, as I said earlier, some of our partners have steam jacketed hot liquor tanks and mash tuns. So not only do you have the electrical in the boiler, now you've got steam, which introduces a whole nother gamut of safety hazards. But they can all be isolated, they can all be contained, and all be dealt with. But just in heating the HLT, whether it's steam or electrical, there are issues there you have to be aware of. Okay, and then you're dealing with over 160 degree. Typically, when we mash in, we're somewhere around 170, 175 before we transfer. So you got some really hot water that's going to have thermal hazards there for your skin. When we mash in, again, we're going to transfer that 160 degree or so water. And then you're going to have trip hazards too. You've got hoses, and if you've been in our partner breweries doing your practicum work or part of these other brews, you'll notice they use a lot of hoses on the ground. It's just the way they have them. Now some of these massive breweries, they've got them to where they are hard piped, and all they've got to do is hit a touch screen, and it shifts a valve and it transfers the liquid to the right vessels and things like that. Well, those are high-end. Those are high-end brew houses and high-end equipment. So we use, as well as most of the breweries around here, a series of hoses that become trip hazards, even though you try your best not to have that exist. Also ladders. Yeah, there's something you can't unsee. But anyway, they got ladders, and anytime you're above ground, you run the risk of falling off the ladder, falling down off that like that. She, by the way, is coming back down in exactly 180 degrees opposite of what you should. You should always come down the ladder facing the steps and with your hands on the rails. But you got ladders, and then again, just another example, some of the heights that you're dealing with. And with it being very slippery, it just exacerbates the situation. And again, we talked about lifting during the mash-in process, okay? We do that as well, okay? And then we don't have this mechanical issue in the lab, but like I stated earlier, we have it at some of our partner breweries that have the Raking Plow system. As far as Warlock, we're looking at about 152-degree recirculation of that mash, trying to clear it up, and it can get hot. And also, we're doing it with hoses on the ground. There'll be trip hazards there as well. And again, just another example of those trip hazards. When we get to the boil, this is where we get the water or the wort to 212 degrees. And you got steam, which is not only just 212 degrees, it's closer to 350, it's superheat. So if that system is equipped such, you're going to be dealing with steam, and again, electrical and the steam and boiler components as well. We transfer that wort. Again, you're handling 212. Truthfully, when it comes out of the boil kettle going into the heat exchanger, it's probably closer to about 205 degrees, but still very hot temperature that you don't want to have your bare skin exposed to. And again, trip hazards with that, with the hoses. Packaging, whereas we keg, okay, we put that under a lot of pressure, but some of our partners have canning and bottling machines, so you got risk of hand injury with glass and metal, and also when you're kegging, you're dealing with pressurized vessels in not only the fermenter, but the kegs as well. And then this one, I like this little file here. That was a great save. The guy, obviously that's an empty keg, I would think. That guy had his arm ripped off. But mobile equipment just really, it really creates a whole another series of hazards in the brewery. If you ever been anywhere, or if you ever go anywhere that's got a fork truck, take a look at the back of it. It's always got some kind of typically yellow or green paint scuffs on the back of it, where operators have backed into poles or backed into equipment. The green paint is kind of telltale signs. You ask them about it, and they've never seen it before, or that fork truck came from the factory that way, or they have no idea how it got there. But just next time if you see one, take a look in the back, and chances are you're going to see some scuff marks from where they've run into stuff. But anyway, anytime you bring in mobile equipment, that just really ramps up your chances for an accident. In this particular case, you've got a hydraulic cylinder holding up these kegs, and again, these hoses that feed fluid to and from that cylinder are going around a reel, and they've got bend points, and they get weak, and they could suddenly burst and oil come out the side, and you've lost your pressure. And if it's under a load, that load's going to hit the ground just like that. You never want to be under that. You don't want anything under that that could get damaged or hurt in the way. But again, my point being that mobile equipment just brings up a whole nother array of hazards. But that's what I've got for you right now. Like I said, I just want to keep this kind of short and sweet. There's a quiz going to be here on Blackboard, as well as some additional reading material. I think we're going to have a discussion board. But I didn't want to dive real deep into it. I just wanted to kind of make you aware of some of the hazards. Maybe you've not thought about them, but maybe now you will, and it'll make it make you a little more safe as you go into work at these breweries or do the practicum hours and things like that. That's about what I've got for you right now. If you've got any questions, please reach out to me. Most of you have my cell phone. You can text or call my office, email me, come by the lab and find me. If you've got any questions, I'll be glad to answer them. Other than that, I want to thank you for watching. Again, this is not the sexiest of topics, but we're done with this one so far, and then we're going to be diving into the electrical. But for right now, I hope you got something out of this, and look forward to you seeing the next video.